discovering requirements, introduction. In the case of interaction design, this includes understanding people who may use the product and their capabilities, how a new product might support people in their daily lives, people's current tasks, goals, and context and constraints on the product's performance. This understanding forms the basis of the product's requirements and underpins design and construction. So the discovering requirements requires to understand the people that use the product and how it might support them in their goals, in their context, and then constraints with a limited technical um, capabilities. It may seem artificial to distinguish between requirements, designs, and evaluation activities because they are so closely related, especially in an iterative development cycle, like the one used for interaction design in practice. They are all intertwined, with some design taking place while requirements are being discovered, and the design is evolving through a series of evaluation design cycles. With short, iterative development cycles, it's easy to confuse the purpose of different activities. However, each of them has a different emphasis and specific goals, and each of them is necessary to produce a quality product. So, this, even though these are interconnected, the mm, requirements, the design and evaluation activities, they are need to be understand in detail because it needs to produce a quality product. So the what, how, and why. What's the purpose of the requirements activity? Requirements may be discovered through a specific requirements activities or during product evaluation, prototyping, design, and construction, along with the wider interaction design life cycle. Requirements discovery is iterative, and the iterative cycles ensures that the lessons learned from any of these activities feed into each other. In practice, requirements evolve and develop as the stakeholders interact with designs and learn what is possible and how features can be used. So it's not just in the first, but we can also discover this in evaluation, prototyping, design, and construction. Along with the wider interaction design life cycle, requirements discovery is iterative. So is prototyping, um, testing, etc. It requires us to continuously learn from any of these activities and feed into each other. So the requirements evolve and develop as the stakeholders interact with designs and learn what is possible and how features can be used. So it's another way of saying that since it's implementing a complex adaptive system, that's another way to explain that. So how can requirements can be captured once they are discovered? Requirements may be captured in several different forms and at varying levels of detail depending on the type of application. So you can find this in different like ways or form in varying detail depending on the application. Interactive products span a wide range of domains with different constraints and the user expectations and the notations used to capture requirements need to reflect this. For some products, such as exercise monitoring app, it may be sufficient to develop a range of prototypes together with product descriptions. So, since interactive products could be a different domain, user expectations and notations, which we have discussed in the previous chapter, used to capture requirements, need to reflect this. For some products, such as an exercise monitoring app, it may be sufficient to develop a range of prototypes together with product descriptions. So there is a lot of details depending on the context it is used. Like a product could be like people that is complex that could be used in different ways depending on context. Uh, that's why these notations and user expectations are used to capture that. For others, such as factories, process control software, a more detailed understanding of the required behavior uh, is needed before prototyping or construction begins, and a structured or rigorous notation will be used. So for some, the more detailed or more complex uh, requirements required because you're building big things. But for some, a short and brief requirements may be sufficient. There are also different kinds of requirements, each of which can be supported by different notations that emphasizes different characteristics. For example, requirements involving large and complex sets of data, such as for an air traffic control dashboard, will be captured using a notation that emphasize data characteristics, while requirements involving technical infrastructure, such as for a smart city, will be captured using a notation that emphasizes devices and their interactions. So there's also different requirements or with the different like diagram or notation that we have discussed earlier. So as we can see, requirements are complex. It's different to different people, different based on where you look at it or what diagram you use. So it's actually not as simple to define what is the requirements because it's different for like different contexts. For example, requirements involving large and complex sets of data, such as for an air traffic control dashboard, will be captured using a notation that emphasizes data characteristics, while requirements involving technical infrastructure, such as for a smart city, will be captured using a notation that emphasizes devices and their interactions. So the notation that will be emphasized for a large data is characteristics of the um, requirements of the data instead of like going all over the entire subset of data. While requirements involving technical infrastructure, such as for a smart city, will be captured using a notation that emphasizes devices and their interactions. So for a smart city, the notation that will be used is the relationship for they emphasize the devices and their interactions with people. So you're zooming in different kinds of requirements depending on or annotations depending on your use cases. Uh, so to answer how can requirements be captured once they discovered, the notation, we use notation, but That depends on different applications. This means that a diversity of both physical and digital representations is used, including prototypes, stories, diagrams, and photographs as appropriate for the product under development. So it means we use like different representation, including photographs, diagram, appropriate under development. In addition to capturing the requirements themselves, criteria that can be used to show when the requirements have been fulfilled will also be captured. For example, measurable usability and user experience criteria. So for requirements, included that is the testing. So how do you test if your requirements has been fulfilled? You also have that testing. Why are requirements important? Discovering and communicating requirements helps to advance this goal because defining what needs to be built supports technical developers and allows stakeholders to contribute more effectively. In safety critical domains such as aerospace, medical, or transport systems, the lack of clear and precise requirements has been one of the main sources of errors. User design with repeated iteration and evaluation, along with stakeholder involvement, can help mitigate against misunderstanding. Hmm. So these requirements are important for you to communicate or to scale what you want to do. So it allows one goal because defining it allows the people that's working on it to communicate effectively, uh, especially in aerospace, medical, or transport system. So the lack of clear and precise requirements has been the cause of their failure. Now, user-centered design with repeated iteration and evaluation along with stakeholder involvement can mitigate against misunderstanding. The process of discovering requirements also promotes communication between all parties and hence a common understanding. Miscommunication and misunderstanding can easily occur if requirements are assumed or are left implicit. This classic cartoon captures problem that can occur very nicely. So here, how the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer write it, how the business consultant described it, how the project was documented, what operations installed, how the customer was billed, how it was supported, what the customer really needed. Mhm. What are requirements? A requirement is a statement about a product that specifies what is expected to do or how it will perform. For example, a requirement for a smartwatch GPS app might be that the time to load a map is less than half of a second. Requirements may also be expressed at different levels of abstraction. So another, less precise requirements might be for teenagers to find the smartwatch appealing. In the latter example, the requirements activity would involve exploring in more detail exactly what would make such a watch appealing to teenagers. So it's basically a statement that specify what is expected to do or how it will perform. What will the product do and how it will perform. So what and how is a kind of basic way to describe it. But basically, it's still different for different product. Here, sometimes not clear what is the what and how. So you need to ask that question as well. Like here, if you don't know anything about technology, here I honestly don't know how the GPS app being measured. So this is the first time I understand how they check that via half a second. So I think that's a useful knowledge. So how to load a map in half a second is by considering different internet connection, different environment, different phone hardware, etc. Requirements may also be expressed at different level of abstraction. So another less precise requirement might be for teenagers to find the smartwatch appealing. In the latter example, the requirements activity would involve exploring in more detail exactly what would make such a watch appealing to teenagers. So if it's there's a less precise requirements for teenagers to find a smartwatch appealing. So you kind of have to break it down. So what makes the smartwatch appealing for a teenager? So that's more abstract, which is harder to find. So here's an example of Volair. Let's just make it bigger. Description. The product shall issue an alert if a weather station fails to transmit readings. So that's the description of the requirements. Rationale. Failure to transmit readings might indicate that the weather station is faulty and needs maintenance, and that the details used to predict findings roads may be incomplete. Source Rose engineers fit criterion for each. God, I can't read it. For each weather station, the product shall communicate. Let's there you go. So for each weather station, the product shall communicate to the user when the recorded number of each type of reading per hour is not within the manufacturer's specified range of the expected number of readings per hour. So for each weather station, the product shall communicate to the user. If it doesn't do that, then it will fail the requirements. Customer satisfaction, 3. Customer dissatisfaction, 5. Conflicts, none. Dependencies, none. Specification uh, of Rosa weather station. So this is the materials they source it. History here. So here's an example. Requirements or the first one of the first way to represent requirements is in a square sheet of paper because you're able to compile a lot of information in a small space. So here the type of the template, list of events or use cases that need this requirement, and then this uh, unique ID, a one sentence statement of the intention of the requirement. So here, guys, it's useful if you could have one sentence always of on what you're trying to talk about. A justification of the requirement. The person will raise the this requirement. A measurement of the requirement such that it is possible to test if the solution matches the original requirement. Priority, a rating of the customer value. Other requirements that cannot be implemented if this one is volatile. Pointer to documents that illustrate and explain this requirement. Creation, changes, deletion, etc. Degree of stakeholder happiness if the requirement is successfully implemented. Scale from 1 equal uninterested to 5 extremely pleased. Measure of stakeholders unhappiness in this requirement is not part of the final product. Scale from 1 hardly matters, 5 extremely displeased. Note that inclusion of a fit criterion which can be used to access when the solution meets the requirement. And also note the indication of customer satisfaction, dissatisfaction, and priority. This shell indicates the information about a requirement that needs to be identified in order to understand it. The shell is from a range of resources collectively called Voliere. So basically, these are the fit criterion in assessing when the solution meets the requirements. So this shell indicates the information about a requirement that needs to be identified in order to understand it. The shell is from a range of resources collectively called Volare, which is a generic requirements framework. Volare is widely used in many different domains, including crowdsourcing for emergency management and autonomous vehicles, and has been extended to include UX analytics. An alternative way to capture product requirements is via user stories. User stories communicate requirements between stakeholders. Each one represents a unit of customer visible functionality and serves as a starting point for a conversation to extend and clarify requirements. User stories may also be used to capture usability and user experience goals. User stories are deliberately brief and are often written on physical cards that constrain the space for information in order to prompt conversations between stakeholders. So basically, the user story start as a starting point for a conversation to extend and clarify requirements. User stories may also be used to capture usability and user experience goals. So if you want one way to like get the usability of your product, you can get one user stories. User stories are deliberately brief and are often written on physical cards that constrain the space for information in order to prompt conversation between stakeholders. So the user stories like Voler is also constrained on a physical card that constrain the space to prompt conversation between people without talking about it. However, digital support tools such as Jira facilitate the attachment of other information to elaborate the user story such as detailed diagrams of screenshots. A user story represents a small chunk of the value that can be delivered during a sprint. A short time box of development activity, often about 2 weeks long, and a common and simple structure for user stories as follows. So Jira provide a more elaborate stories that is could be modified depending on your goals. It could allow you to put like screenshots and diagrams, and it automatically save to the cloud. User story represent a small chunk of value that can be delivered during a sprint. Okay, so basically you're trying to solve a specific problem. So as a rule, I want behavior so that benefit. Example, user stories for a traveler organizer might be. As a traveler, I want to save my favorite airline for all my flights so that I will be able to collect air miles. As a travel agent, I want my special discount rates to be displayed to me so that I can offer my clients competitive rates. Once completed and ready for development, a story consists of description, an estimate of the time it will take to develop, and an acceptance test that determines how to measure when the requirements has been fulfilled. It is common for a user story, such as the earlier ones, to decompose further into smaller stories, often called tasks. So, stories can be decomposed if you want more detail or if you want to dig deep. So, once it's completed, it has a description as well, like bullet, an estimated time to develop, accept a test on how to measure the satisfaction, etc. During the early stages of development, requirements may emerge in the form of epics. An epic is a user story that may take weeks or months to implement. Epics will be broken down into smaller chunks of effort, user stories, before they are pulled into a sprint. Example, epics for a travel organizer app might be the following. As a group, traveler, I want to choose from a range of potential vacations that suit the group preference so that the whole group can have good time. So the requirements as well could emerge from this. So another way to look at requirements uh, is that it could came from a user story. So maybe you were inspired and you want to like solve this user issue or like some thing that one user did that allows you to better understand or learn your product. Then you can also use that as a way. So an epics uh, is like a big thing that take weeks or months to implement. So it's broken down using via user stories before they are put into a script, like a travel organizer app. As a group traveler, I want to choose from a range of potential vacations that suit the group's preferences so that the whole group can have a good time. As a group traveler, I want to know the visa restrictions for everyone in the group so that visas can be arranged for everyone in the group in plenty of time. So yeah, you have two like epics here, but we will divide this into two sprints because that's two user stories. Different kinds of requirements. Requirements come from several sources, from the user community, from the business community, or as a result of the technology to be applied. So it could come from several sources. It could be from user, the business, or the environment, and the technology, which is the artifacts. Two different kinds of requirements have traditionally been identified. Functional requirements, which describe what the product will do, and non-functional requirements, which describe the characteristics, sometimes called constraints, of the product. So non-functional, we already know functional, which is describe what the product will do. But the non-functional actually is the one of the makes it complex because these are the constraints of the product. So with this like limited, I think this is often missing because we think we can always do the things that we want to do, though that might be true. There's always like a limitation. So that's a non-functional requirement. So what's hindering us from doing it, right? Maybe it's knowledge or the environment, the technicalities, or the available phones or computer that will be used to do it. For example, a functional requirement For a new video game might be that it will be challenging for a range of abilities. This requirement might then be decomposed into more specific requirements, detailing the structure of challenges in the game. For instances, level of mastery, hidden tips and tricks, magical objects, and so on. So, the functional requirements for a new video game is it will be challenging for a range of abilities, so for a range of user. So it will be decomposed into more specific requirements detailing the structure of challenges in the game. For instance, level of mastery, hidden tips, tricks, magic objects, and so on. A non-functional requirements for this same game might be that it can run in a variety of platforms such as the Microsoft Xbox, Sony PlayStation, and Nintendo Switch game systems. Interaction design involves understanding both functional and non-functional requirements. Functional requirements capture what the product will do. For example, a functional requirement for an automated industrial assembly plant might be that an operator can program assembly line to identify, manipulate, and weld together the correct pieces of metal accurately. Understanding the functional requirements is fundamental for all products. So for an assembly plants, they actually have an program assembly line that identify, manipulate, and weld together the correct pieces of metal accurately. So understanding this is fundamental to all products. Basically, you need to understand what this product will do for you with this clear goals or requirements to achieve your goals. Data requirements can capture the type, volatility, size or amount, persistence, accuracy, and value of record data. All interactive products have to handle some data. For example, if an application for buying and selling stocks and shares is being developed, then the data must be up to date and accurate, and it is likely to change many times a day. In the personal banking domain, the data must accurate and persists over many months and probably years, and there will be plenty of it. Environmental requirements or context of use refer to circumstances in which an interproduct will operate. Four aspects of the environment led to different types of requirements. First is the physical environment, such as how much lighting, noise, movement, and dust is expected in the operational environment. Will workers need to wear protective clothing, such as large gloves or headgear, that might affect the choice of interface type? How crowded is environment? For example, a ticket machine operates in a very public physical environment. Thus, using a speech interface is likely to be problematic. So, the second aspect of the environment is the social environment. So, let's back up a little bit for this. Like lightning, noise, and dust, those are the things that exist in the environment that you may not be aware. Uh, So that will affect the operational environment. And a lot of times, like people don't know what's the available choice because they just don't put in the work to know what's the available choice, or it's just not their area of expertise. So knowing that is one of the reason why it's hard to like learn the requirements, just the requirements or the goals. Will workers need to wear protective clothing such as a large gloves or headgear that might affect the choice of interface type? How crowded is the environment? For example, a ticket machine operates in a very public physical environment. Thus, using a speech interface is likely to be problematic. So yeah, a lot of things to consider, guys. The second aspect of the environment is the social environment. For example, will data need to be shared? If so, does the sharing have to be synchronous, such as for two people viewing data at the same time, or synchronous, such as when two people are authoring a report, taking turns to edit it? Other factors include the number of people needing to interact at once in a video game and the locations of friends or colleagues. This third aspect is the support environment. For example, what kind of assistance will be needed to use the product and how easily can it be obtained? How much training or help will be available? And what level of help can be provided automatically? These issues need to be explored during requirements activity, and there are user experience implications in choosing one solution or another, as discussed in the dilemma box. Automated help or customer service support. Several service providers, such as energy companies and government uh, offices, have strive to improve their online presence to make it as comprehensive, clear, and streamlined as possible. Customers who encounter difficulties are encouraged to seek help through the various fax, online chatbots, and support forums rather than to contact the provider directly. Customers whose goal is to do something that is regarded as standard are well supported, but as soon as they query steps outside of these dimensions, it can be hard for the system to find an answer. How good user experience does this create? On one hand, for those who are able to complete their goal quickly and easily, the system provides a good user experience. But for those with an issue that sits just outside the norm, the steps setup can be a poor experience. The dilemma comes in deciding how much to rely on online support and automated systems and how much to include human interaction. Finally, the technical environment will need to be established. For example, what technologies will the product run on need to be compatible with, and what technological limitations may be relevant. User characteristics capture key attributes of potential users, such as their abilities and skills, and perhaps their educational background, preferences, personal circumstances, physical or mental abilities, and so on. In addition, someone may be a novice, an expert, a casual user, or a frequent user. So those are characteristics as well that help us determine the requirements. As you can see, it's very complex just to know what is your goal. This is the reason why it's 50% of the goal achieved once you do this. This affects the way in which interaction is designed. For example, a novice user may prefer step-by-step guide. An expert, on the other hand, may prefer a flexible interaction. For example, a novice user may prefer step-by-step guidance. An expert, on the other hand, may prefer a flexible interaction with more wide-ranging powers of control. So, different person, you're dealing with different person here because for expert, you want a more functionality, even it's the GUI is complex. The term user profile is used to refer to a collection of user characteristics. Any one product may have several different user profiles. For example, a client user profile and an agent user profile may be developed for a financial management portal, while profiles for a young parent with two children and a mature business person may be developed for a mobile library catalog interface. So, these user profiles, we will discuss that in detail later. So, it also defines the characteristics of the user of the product. So it's part of user characteristics. Usability goals and user experience goals. What is interaction design? Are another kind of requirement. So how usable, which we discussed this in chapter 1. Considering each of these kinds of requirements is starting point to discovering the requirements for a particular product. So again, uh, doing this, all of this environmental data requirements, functional, non-functional, these are just the starting point, guys. Um, but you will continue to find it along the development. But it's a high-level perspective that will need to be refined. For example, a telecare system designed to monitor someone's movements and alert relevant care staff will have a range of environmental requirements, including that the device need to be light, small, fashionable, preferably hidden, and work easily as people go out their normal activities. So you also have to need to agree with all the people or stakeholders. Uh, let's say you have a meeting with the stakeholders of this product, and someone didn't agree, which could hinder the project. So that's also a requirement to persuade that person. So here, that's how you like get more requirements, or you discover the requirements. That's why it's very important to be open to change, to be anti-fragile, you know. The requirements activity will investigate what that means in detail. A desirable characteristic of both an online shopping site and a robotic companion is that they are trustworthy. But this would be interpreted differently in each case. In the former, security of information would be priority, while in the latter, behavioral norms would indicate trustworthiness. So different product as well value different characteristics or requirements. Some they will value security, but for others they will value the convenience. The seven product dimensions shown in 11.2 are intended to be used as prompt to ask questions about the product from different perspectives: the customer, the business, and technology. The Voller template shown in table 11.1, which we discussed, has more detailed framework, including the waiting room. This is where solution ideas can be parked while divergent thinking continues. So here, user interacts with the product interface, connects the user to system, action, capabilities for user, data, includes a repository of useful information, control, uh, the constraints, environment, controls the physical and technologically platforms, quality, attribute. So later we will also discuss how these, the requirements and the build up, the careful build up or understanding of these steps in each cycle of development provide a long-term product. So have you ever wondered why some products don't last long while other products last longer because they develop a good requirements. So here, uh, an example of more detailed, comprehensive categorization of types of requirements. Project drivers, the purpose of the product, the stakeholders, project constraints, mandated constraints, naming conventions and terminology, relevant facts and assumptions, functional requirements, the scope of the work, business data model and data dictionary, the scope of the product, functional requirements, scope of the product is included in functional requirements, business data model, and data dictionary. So the data model is included in functional, non-functional, look and feel requirements, usability and humanity requirements, performance requirements. So performance, you may think it's for functional. No, it's actually in non-functional. Operational and environmental requirements, it's in non-functional. Maintainability and support requirements, non-functional. Security requirements, non-functional. Cultural requirements, non-functional. Compliance requirements, non-functional. So as you can see, guys, a lot of things that really matter, especially for longevity of the product, is inside the non-functional requirements. So the project constraints is the mandated or the budget of the project. The purpose of the product and the stakeholders is the drivers of that project. So the people that's affected. Relevant facts and assumptions. Project issues, open cases, off-the-shelf solutions, new problem, task, migration to new product, risk, cost, user documentation and training, waiting room, ideas for solutions. So here, these are the issues, the documentation and training, the waiting room, ideas for solution. So cost, risk, migration to new product, task, new problem. So it's about like how you will resolve the problem. Now I think we'll continue with this activity tomorrow. Uh, and we'll continue with data gathering for requirements. So for data gathering, see, we use using probes. We introduce new way for data gathering, contextual inquiry, brainstorming for innovation, and then bringing requirements for lives and personas. Uh, so we will discuss personas and scenarios, how it relates to the goal. And then yeah, we're gonna watch video, capturing interaction with use cases. So we're gonna check that as well. And yeah, um, we're done. And then yeah, thank you for watching and see you on the next video. Peace.